Hello, I'm Erin, Powell, an undergraduate mathematics major with Stephen F. Austin State University. My research project is over the p-adic valuation of two different Fibonacci-like sequences. I specifically looked into the 2-adic valuation, so prime of p equals 2. The 2-adic valuation is when you take an integer's prime factorization. The exponent associated with the power of 2 is the integer's valuation. A couple of examples of 2-adic valuations are the valuation of 18 being 1, as 2 to the power of 1 is the greatest power of 2 that occurs in the prime factorization. The valuation of 5 is 0 because there are no factors of 2. Fibonacci-like sequences can be written in a simple recursive form where you add terms according to some rule. The first Fibonacci-like sequence I looked into can be found on the online Encyclopedia of Integer Sequences website. This sequence is defined as the addition of two consecutive prime numbers. While I may not be able to write a closed formula for this sequence due to its dependence on prime numbers, I was still able to categorize the sequence's behavior in its 2-adic valuations. This prime number Fibonacci-like sequence could be simply defined by two statements. The sequence itself is unbounded, and the 2-adic valuation sequence is unbounded. The second Fibonacci-like sequence I looked into is a traditional Fibonacci sequence, but the n-1 term is doubled every time. The sequence had multiple cases depending on the chosen starting values. The first case is when f sub 2 is odd. This case will always result in a valuation of 0 for all values in the sequence following f sub 2. The second case was when f sub 2 could be defined as 2 times f sub 1. Whenever this happened, the valuation sequence was unbounded, and I was able to find a formula. I also looked into the third case in which I was unable to find a formula. While this is research into pure mathematics, there are surprisingly some practical applications. P-adic numbers are used when researching complex number fields and number theory. These fields of mathematics can then be applied to various fields of science, such as cryptology, quantum mechanics, and topology. I would like to thank the S.U.R.E program for sponsoring this research project.